Hi everyone, welcome to session 29 of our Java programming course. In this session, we will dive into result set handling in JDBC and do some practical exercises. I am Dr. Amit Batra. I will guide you through understanding how Java works with database query results. Before we start, let us quickly recap what we covered last time. We looked at JDBC basics, including driver manager for connecting to databases and the statement and prepared statement objects for executing queries. We also learned how to handle SQL exceptions and make sure our connections are properly closed after use. This will be important because result set builds on these concepts. Here is something to think about. Imagine you are making a student portal. You run a select query to list students. How does Java keep track of each row? Can you jump directly to say the 10th student? And can you update a student's marks directly without writing a separate SQL update? These are the questions we will answer today. By the end of this session, you will be comfortable with result set in Java. You will learn how to navigate through rows, move to specific records, and even update, insert, or delete rows directly from a result set. We will also do exercises to apply these skills practically. Here is our roadmap for today. First, we will cover the basics of result set, then the different types and concurrency modes. Next, we will learn how to navigate rows, how to update data directly, and finally, we will do practical exercises to reinforce everything. Result set is essentially a table of data returned by a query. When you execute a select statement, Java stores the result in a result set object. It has a cursor that points to the current row. By default, the cursor is before the first row. And we use methods like next, previous, first, and last to move it around. There are different types of result sets. Type forward only allows you to move forward. Scrollable result sets like type scroll insensitive and type scroll sensitive let you move both forward and backward. The difference is whether changes in the database are reflected in the result set. Concurrency modes control whether the result set can be used to modify the database. Read-only result sets only let you read data. Updatable result sets let you insert, update, or delete rows directly. Choosing the right type and concurrency depends on what your application needs. This code shows how to create a scrollable and updatable result set. We first establish a connection, then create a statement with type scroll insensitive and concur updatable. Finally, we execute a select query to get our result set. These are the main navigation methods. Next method moves to the next row. Previous method goes back. First and last method go to the first or last row. Absolute method jumps to a specific row. Relative method moves relative to the current position. And before first or after last methods, position the cursor outside the result set. This example shows how to loop through the result set using next method to print each row. Then we move to the last row using last method and prints its ID. This demonstrates how to navigate and access data. Updatable result sets allows us to modify data directly in memory. Using update methods, you can change values. Insert row method adds a new row. Delete row method removes a row. And refresh row method reloads data from the database. This is useful for small to medium size data set. Here is an example. We move to the third row and update the marks to 95.0. Then we insert a new student by moving to the insert row, setting values, and calling insert row. Finally, we return to our previous row using move to current row method. For your first activity, write a Java program to fetch student data. Use navigation methods like next method, previous method, first method, and last method to explore the result set. Print student ID, name, and marks as you move through rows. The second activity is about modifying data, create an updatable result set, and update a student's marks, insert a new student, and delete a low performing student. Then run a select query to verify your changes. In groups, write a JDBC program to display student or employee data neatly in a table. Experiment with navigation methods to move around and understand how the result set behaves. For homework, retrieve the top 5 highest scores from the students table, display rank, student name, and marks. Use result set navigation methods to verify positions like first method, last method, or absolute method. To summarize, result set stores query results in Java. Its type and concurrency mode determine how we navigate and whether we can modify data. Navigation methods make moving through rows flexible and updatable result sets let us directly insert, update, or delete records. Reflect on what you learned today. Which result set feature do you find most useful and why? In the next session, we will move on to managing transactions. So now we would like to solve our case-based cum scenario-based programming problem. The problem is in front of us. A university management system uses JDBC to display and update student records. We have to solve these three subparts. Design is first A part is design a Java program that retrieves student data using an appropriate result set type. B part is extend the program to allow updating records using result set methods. C part is critically analyze best practices for efficient and secure result set handling. So first of all, we'll be solving a part, that is we'll be designing a Java program that retrieves student data using an appropriate result set type. First, we will open the workbench and create a database named university2 using this database university2 using use statement, creating table student named students and with three fields or three columns. ID, data type is integer and constraint is primary key. ID cannot be null, it is unique. Name, data type is varchar, that is variable number of characters. At most, name can contain 50 characters. Constraint is not null, meaning name cannot be null. Marks is double. Data type is double, that is marks will be of double data type. Then we'll be uh, executing this insert query and inserting these records into the table named students. ID 101, 102, 3, 4, and 5. Name as Alice, Bob, Charlie, David, and Eva. Marks are respectively 85, 78.5, 92, 65.5, and 55. I have already executed these queries, so I will not be executing again. Otherwise, result mismatch can be there. Now we are in a position to write our Java program. So open IntelliJ IDE and I have created a project named ResultSet example and as usual as we are doing in the previous sessions. So here we will use a scrollable and read-only result set for navigation. This allows moving forward and backward through records without updating the database. First line is import java.sql.star. This imports the Java SQL package which contains all the classes we need to work with databases like connection, statement, and result set. Essentially, it gives Java the ability to talk to our MySQL database. Then we are having line number 3, that is public class main. This defines our main class main. All our database code will run inside this class. Then we are having line number 4, that is public static void main, and this is the entry point of the program. When we run the program, Java executes everything inside the main method. Then we are having string URL equal to path of the database named university2 and on we are using port number 3306. Then we are having a root user and then we are having the password which we have set for the root user while installing the MySQL community server. So these three lines, line number 6, 7, and 8, these three lines specify the database details. The URL points to our MySQL database named university2 and root is the user and password is the disturbance I have set. So next we move to line number 10 to 12. Connection class object con is null. Statement object stmt is null. Result set object rs is null. So we declare the JDBC objects. Connection is used to connect to the database. Statement is used to execute SQL queries. Result set will hold the results returned by the database. Then we jump to the line number 16, that is connection object con is equal to driver manager dot get connection, and we pass URL, root user, and password as the parameter. So this connects to the database using the parameters we defined earlier. Driver manager dot get connection method returns a connection object if successful, that is if connection is successful. Then we move to line number 19. Statement object stmt equal to con dot create statement result set dot type scroll insensitive comma result set dot concur read only. Here we create a statement object with specific properties. Type scroll insensitive means the result set can move forward and backward but won't reflect changes made to the database after it is created. Concur read only means we can only read data and cannot update it through this result set. Then we move to line number 25, that is string SQL. We write select query into it. And line number 26, R result set object rs equal to statement object stmt dot execute query, and we pass SQL as a parameter. So we define a SQL query to select student ID, name, and marks from the students table. Execute query runs the query and stores the results in the result set object rs. Then system.out.println student records, system.out.println ID, name, and marks. This prints a header for our output, making it easier to read the student records in tabular form. Then we jump to line number 32. That is the while loop rs.next. So this represents the forward navigation. Int id is equal to rs.get int id. String name is equal to rs.get string name. Double marks equal to rs.get double marks. System.out.println id plus name plus marks. So this loop moves the cursor forward row by row. This loop moves the cursor forward row by row using rs.next. Get int id, get string name, and get double marks retrieve the respective column values for the current row. We print each student's ID, name, and marks. Essentially, this loop prints all student records in the table. Then we move to line number 40. That is, if rs.last system.out.println last student record system.out.println rs.get int id plus rs.get string name and plus rs.get double marks. So here we demonstrate random access. Rs.last method moves the cursor directly to the last row. Then we print the last student's details. This shows that scrollable result sets allow jumping to any row without looping through all rows. Then we are having the catch block in line number 45 to catch any exception. So this block catches any exceptions like connection failures or SQL errors and prints the error stack trace so we can debug issues. Then we are having the finally block, line number 47. We are having three different try catch blocks. If rs is not equal, result set object rs is not equal to null, we close that. If statement object stmt is not null, we close. Connection object is not equal to null, con dot close. So this ensures all JDBC resources are closed properly even if an error occurs. Closing result set, statement, and connection frees up memory and prevents database locks. This is considered best practice in JDBC programming. So the summary is connects to the university database, university 2 database, executes a select query to fetch student records, uses scrollable result set to navigate rows, print all records and demonstrates accessing the last record directly, handles exceptions and closes all the resources safely. So move to project structure, and again we have given the path to the jar file as usual. Now we are in a position to run this program and build process starts here. And we can see here this is the result of our executing our program. So it displays the student records in the form of a table, ID, name, and marks, which we have inserted earlier using the workbench here. As you can see here, these were the inserted records, and these inserted records are now displayed as results of this JDBC Java program. And obviously the last student record fetched is with ID number 110, name is Ria, and marks are 88.5. Uh, so this is the result. Why we are getting this last record as student record as 110 as Ria 88.5. Since we have not inserted here, let us check this why the last record is 110 Ria 88.5. So let us check this. Huh. Because of I have inserted one more query onto this University 2 database. That is, we I have inserted this row with the value ID as 110. Name is Ria 88.5. So that's why the last record is here showing as with ID 110. Student name is Ria and marks are 88.5. So we have successfully solved our A part. That is, we have designed a Java program that retrieves student data using an appropriate result set type. Now we have to extend in the B part, we have to extend this program to allow updating records using result set methods. So first of all, we'll in the workbench, we'll be writing this update query that is update students set marks is equal to 95 where ID is equal to 101 and where the marks were uh, where the ID was 101. So as you can see, when the ID was 101, the marks were 85. But now we are updating these 85 marks. The marks will be replaced by 85 marks will be replaced by now here 95 because we have executed this update query. And then the normal insert query. And then we delete all the records where marks are less than 40. So here uh, we are not having any marks less than 40. That's why no row will get deleted. So to update, we need concur update table. Now we'll be writing our Java JDBC program. I have already written it. So this is the program. So line as usual, line number one is import java.sql.star. And this imports the Java SQL package, giving us access to JDBC classes like connection, statement, and result set. We need this to connect to the database and manipulate student records. Then we are having the main class, line number three. This defines our main class main. All our JDBC operations, including updates, inserts, and deletes, are handled here. Then line number four, public static void main. The main method is the entry point. When the program runs, Java executes all the code inside this method. Then line numbers 5 to 7, as usual, URL, root user, and password. These strings define the connection to our MySQL database. The URL, username, and password. The database here is University 2. Make sure database and table exists with the correct name. Then we are having line number 9 to 11, that is connection object con is null, statement object stmt is null, result set object rs is null. These variables hold the JDBC objects, connection to connect to the database, statement to execute queries, and result set to store the query results. Then we are having line number 14 in the try block, con is equal to driver manager dot get connection. We pass these three parameters as URL, username, and password as the parameter to the get connection method. So this line connects to the MySQL database using the provided credentials. Connection object con will be used to create statements and queries. Then we are having line number 17. Statement object stmt is equal to con dot create statement result set dot type scroll insensitive comma result set dot concur updatable. So we create a statement that allows scrolling, that is move forward and backward in the result set because of type scroll insensitive, and statement also allows updating, modifying data directly to the result set because we are using concur updatable. This is essential for updating marks, inserting new students, and deleting rows. Then we are having line number 22, rs equal to statement object stmt dot execute query, and we pass select query as a parameter. So this retrieves all student records from the students table. The result sets are stored in result set object rs, which we can navigate and manipulate. Then we are having line number 27, while loop, while rs dot next. If rs dot get int id is equal double equal to 101, so this is the if condition. Then rs dot update double marks comma 95.0 rs dot update row system dot out println updated student id 101 marks to 95.0. So here rs dot next method moves the cursor forward row by row. Get int id checks if the current student's id is 101. Update double marks comma 95 changes the marks in memory. Update row method commits the change to the database. So this updates student 101's marks safely, and then we move to line number 38, that is int new student ID is 110. So this is the desired ID. Now we check if this ID already exists. rs dot before first, line number 41. 42 line number boolean exists equal to false, then while loop is there rs dot next. If rs dot get int ID is double equal to new student ID, line number 44 exists equal to true, then break statement. Then we are having line number 50. If condition is there, if not exist, rs dot move to insert row, rs dot update int id comma new student id, rs dot update string name comma ria, rs dot update double marks comma 88.5, rs dot insert row, rs dot move to current row, system dot out dot println inserted new student ria with id plus new student id. And the else part is system dot out dot println student with id plus new student id plus already exists keeping insert. So here we check for duplicate IDs using the rs dot before first statement, as you can see here, line number 41. That is rs dot before first method moves the cursor to the start, then the loop checks if the new student ID already exists. This while loop. This loop checks if the new student ID already exists. And then we are having this line number 51. Line number 51, move to insert row, prepares a blank row for insertion. And 50 line number 52, update int method sets column values, then insert row. Line number 55 commits the new student, and then line number 56, move to current row method returns to the previous position. So it prevents duplicates. If id exists, the program skips the insertion, avoiding the sql integrity constraint violation exception. Then we are having line number 65, rs dot before first, then again while loop, rs dot next. If condition rs dot get double marks less than 40, system dot out dot println deleting student plus rs dot get int id, rs dot delete row in line number 69. So this code moves to the start of the result set, checks each student marks, deletes students scoring below 40 using delete row method. All deletions are performed safely through the result set. Then we are having the finally the catch and finally block. So catch block catches any exceptions like connection failures or SQL errors. It prints the stack trace for debugging. Then we are having the finally block, which closes the result set, statement, and connection to free up resources, and it prevents memory leaks or locked database rows. So the summary is this program safely updates student 101's marks, inserts a new student only if the ID is unique, deletes students with low marks that is less than 40, avoids SQL integrity constraint violation exception by checking IDs before insert. Uses scrollable, updatable result set for easy navigation and modification. Now we are in a position to run this program by pressing this run button. Build process starts, and now we can see the result as updated student 101 marks. So as you can see, marks for the student with ID 101 has been changed to 95, which was earlier 80. I think it was 88.5. Clear? And student with ID 110 already exists. That's why It is printing, skipping insert, as you can see here. This statement. This statement, line number 59. That is because the student ID 110 already exists. That's why it is skipping insert because this if statement become false. This if statement become false. That is if, if not exists, but the ID 110 already exists. That's why the else part is executed and the it prints student with ID 110 already exists and skipping insert. That's why it will not be inserting again. It will skip the insert operation. So we have successfully solved the problem sub part B. Now the C part, critically analyze best practices for efficient and secure result set handling. So best practices are as follows. Number one is choose the right result set type and concurrency. That is use type forward only plus concur read only for large result sets. Scrollable, updatable result sets are convenient but memory heavy. Second, close the resources promptly. Always close result set, statement and connection in finally or try with resources to avoid memory leaks. Third is use prepared statement for queries. It prevents SQL injection. It is efficient for repeated queries. Fourth is limit data retrieval. It avoids select star on large tables. Use where and limit to fetch only required rows. Fifth is avoid holding result set open for long. That is fetch data, process quickly and then close. Long-lived result sets can log database rows and degrade performance. Sixth is handle exceptions gracefully. That is always catch SQL exceptions and log meaningful messages. Seventh is transactional safety. When updating multiple rows, use transactions with commit and rollback to maintain data integrity. Eighth is use caching for repeated reads. For frequently accessed data, consider caching in memory to reduce repeated database hits. So the summary is in the A part, we have retrieved the student data using scrollable result set. In the B part, we have performed update, insert and delete records using updatable result set. And C part, efficient and secure handling ensures performance, security, and data integrity. Thank you for watching this lecture. Keep practicing and see you in the next lecture. Please like, share, and subscribe for more Java programming tutorials.